Okay. Good morning, Year 7. So, what we're going to do today is we're going to be looking at magnetic fields. So, the first thing I'd like to do is a bit of a recap from last lesson. I want to use these key words to write a statement about magnets. Now, here are some words that you could use. What statement could you make about magnets? Okay, based on what you learned last lesson. So, I'm just going to pause the video and I'd like to come up with three statements. Okay, so three different statements about magnets. Off you go. So you could have had a statement such as a magnetic material is iron and steel, or you could have had copper and zinc are not a magnetic material, or you could have had magnetic materials have a north and a south poles, or magnetic materials attract other magnetic materials, or anything along those lines, really. Okay, so have a think about the statements you could have made and maybe try and adjust them now. Okay, so today we are learning about magnetic fields, and all of you should be able to describe the term a magnetic field. Some of you will be able to explain the shape and direction of a magnetic field and explain observations of an experiment. Now, last lesson I showed you this picture. What is the law of attraction? Right. Now, if you have a south pole next to another south pole, you see the arrows show that they're pushing apart. They'll repel. Same is true of a north pole next to another north pole. They'll push apart. They'll repel. However, if you put the north pole next to a south pole, they'll attract. They'll come together. What we're going to try and do today is understand why this is. So, it says in pairs, but obviously you'd have to think for yourself. Where is the magnet the strongest? Is the whole of this magnetic? And how do we know that? Okay, so where is the magnet strongest? Well, normally we'd do an investigation to examine this, so I'm going to show you this in just a moment. Is the whole of this magnetic? Again, I'm going to show you that in a minute. And how do we know? Right, so what we would do is we would have done an experiment like this. Now, what we would have done is placed a magnet and some iron filings under a piece of paper and then sprinkled the iron filings. And because iron filings are magnetic, they would have lined up in the shape of the magnetic field and we would have got something like this. Okay, I'm going to ask you to draw this and think, right, what does this look like? Well, there's the north and the south pole of the magnet, so north and south pole. Okay, and you can see it seems to be almost forming like these lines going from the North Pole around to the South Pole. Okay, and if we have a closer look, if we model this, that is exactly what happens. Now, I think I asked to draw this last week, but if you haven't, can you please now draw this in your book? This is the shape of a magnetic field, and what happens is it flows or fluxes from the North Pole around to the South Pole. So North Pole is attracted to a South Pole. So if a magnet is on its own, the magnetic field will flow from its own North Pole round to its own South Pole, like this. And we could see these would join up. And the arrows show the direction which it flows. So just in case, can you make sure you draw that in now, please? Okay, so I'd like to write these two questions in your book and then leave a little bit of space underneath and try and answer them based on the diagram I just showed you. This will take you about 2-3 minutes to do it properly because you'll need to write more than just one word. Okay, so what is a magnetic field? So look at the diagram and describe it. Okay, and then describe the direction and shape of the magnetic field lines. Think about this. Okay, so I'm just going to pause the tape. Again, do that, probably take you about 4 or 5 minutes. And now, question 3 and 4. What is the relationship between the distance of the field lines and the strength of the magnet? And what happens if we put a magnetic material within a magnetic field? Now, the magnetic field, the force lines are very close together here at the poles. That should tell you something. Okay, it tells you the magnetic field is strongest there. If you go back to this diagram, look at how the iron filings bunch together at the poles. Okay, so the fact the field lines are close together means that is where the magnetic field is strongest, at the poles. Okay, so you can answer question 3 now. Question 4, what happens if we put a magnetic material within a magnetic field? Now for this one, you're probably going to have to do this one yourself. So what I suggest you do is go and grab a fridge magnet or something like that around the house. And if you have something which is made of steel, like a steel pan or something, put that between the magnet and, say, a pin. Is the magnet still attracted to the pin? And then try doing it between a piece of plastic and see if it still works. Okay, and then hopefully you should be able to answer question 4. So that'll probably take you a few minutes. So I'll pause the video now and you can go off and do it. Now, the reason a north pole and a south pole of a magnet attract together is, remember what I said here, a north pole will always try and find its south pole. Now, when a magnet is on its own, it'll find its own south pole. But if it's put next to, say, another magnet, it'll find the south pole and be attracted to the south pole of that magnet. And that is why they stick together like this. That's why they're attracted. Okay, so what I'd like to do is draw this out and explain what is happening here. So the north pole of this magnet is attracted to the south pole of this other magnet, and so that is why they stick together. Now, why do we say a north and a north pole repel? Well, again, it's still trying to find a south pole, so if it comes close to another north pole, it's just not interested. The field lines, the force field lines, push away to try and find a south pole. So that is why when you try and push two north poles together, they will repel. So again, can you draw these into your book, please, and explain why a north and a south pole will attract, but a north and a north pole will repel? So pause the video now, copy these into your book with a couple of sentences to explain each one. Off you go. Now, magnets can also be very useful because they can be used to navigate by using a compass. So how do we find north? Well, essentially, this is what we do. Why do people use compasses? Because they help us navigate. But what actually is a compass? Now, I'm going to ask you to pause the video one more time, and I want you to look up what a compass is. So do a very quick Google search, and I'm looking for a very short paragraph, so maybe 5-6 lines in your book, no more, explaining what a simple compass is. Okay, so what is a compass? How does it work? Off you go, please. So essentially, a compass is a magnet in its own right. So what will happen is a compass is a miniature magnet. It has a north pole and it has a south pole. The difference is it's free to spin. Okay, so it'll spin on this top here. And what it does is it lines up with the Earth's magnetic field. Now, the Earth is itself a giant magnet with a north pole and a south pole, although you'll actually learn one day that actually that is a magnetic south pole. So let's just say this compass had a north pole. There's this little compass, it's got a north pole there and a south pole there. So there's this compass there. The reason it points north is because it's attracted to the North Pole. Now, some of you might have already seen the problem here. If that's a North Pole and it'd be pointing north, that would make this up here the South Pole and that the North Pole. And that is exactly right. Earth's magnetic field, although we call it the North Pole, magnetically, it's actually a South Pole. The reason we call it the North Pole is because our compasses always point north because they're attracted to the South Pole, which is actually up here. So it's a bit weird, okay? But these compasses, because they're in Earth's magnetic field, they'll spin and they'll always point north towards this pole here, which is actually a South Pole, okay? So What I would like you to do is draw out Earth's with its magnetic field around it, because Earth itself is a giant magnet. Okay, and then explain how a compass works. So very simply, the miniature North Pole and South Pole on a compass are affected by Earth's magnetic field and will point towards the Earth's either south or north pole, depending on which way you look at it. Okay, so just sketch this diagram out, okay, and just explain what happens. If you need to, you can obviously do a double check and research yourself. Now, once you've done that, I'm going to put a video link online for you to try and understand a little bit more about the Earth's magnetic field. So that'll be the second video link which I put in. So once you've drawn this out, click on that and you can use that to help explain this if you like. Off you go, please. Okay, and finally, to check your understanding, in assignments, there are two activities for you to do. One is to test your basic knowledge of magnetic fields, and the other is to see an example of how certain animals use magnetic fields to navigate. Each sheet should probably take you about 5 to 10 minutes each, okay? And then you can upload those through assignments, okay? Right, so good luck. I'll be online if you get stuck.